Here we present a video tutorial on the RiboVision Layer Manager. RiboVision is intended to allow you to visualize multiple levels of information simultaneously. RiboVision uses the concept of multiple layers, just like Photoshop or Illustrator. Open the Layer Manager by clicking the topmost button of the toolbar located on the right side of the website window. Each of these items in the Layer Manager is an individual pre-created layer. Each layer has a type that determines which dataset can be loaded and stored in it. The layer type can be seen upon clicking and expanding the properties of a layer.
This layer here is where we store interaction data. Its function is to show the interactions between nucleotides with lines. This layer is for labels, and this layer for nucleotide letters. These two data layers depict nucleotide-related information with circles. The data layers are currently empty. Finally, the selection layer stores the circles representing the active selection. See our selection video for more information on selections.
First, let's put some data in the nucleotide layer. To do this, click on Domains in the Structure Data section, and we see that the letters are now colored by domains. But what if you would like to see another layer on top of the letters? Let's say we would like to see the proteins on top of domains. In order to do this, we need to put the protein data into a circle data layer. First, we rename Data 1. To do this, we double-click Data 1 and rename it to protein_contacts. You may optionally change the color associated with this layer. Click Save to update layer preferences.
To load data to a layer, we first choose, for example, our newly named protein contact layer by marking it as the selected layer. This is controlled by the S column of radio buttons here. Only one layer at a time can be selected. When a layer is marked as selected, any data loaded from the main menu will be loaded to the selected layer. Selecting a layer allows you to control which layer is displayed in Navline, clear data, or delete a layer.
If we reselect the protein contacts layer, you will see that our nav line is still blank. That's because we haven't added the protein contact data yet. To do so, go to the Protein Data section in the main menu and select which proteins you would like to see. I am going to choose all of them by clicking on Check All. This is a list of all ribosomal proteins, which were seen in this particular crystal structure. Note that some structures may not include all ribosomal proteins. The protein data will draw on the currently selected protein contacts layer, and the RNA nucleotides that are in contact with proteins now have circles above the nucleotide letters. The proteins also show up in the JMOL panel. You can also see that the nav line has been updated with protein contact information.
Each layer can be expanded or collapsed by single-clicking to reveal layer options. Inside our protein contacts layer, you can change the properties of the circles. The circles can be filled or unfilled and set to regular size or large size. You can also change the ordering of the layers. For example, if you would like the letters to show up on top of the circles, drag the nucleotide layer above the protein contacts layer, or drag the protein contacts layer below the nucleotide layer. Let's turn the protein contact circles to large and unfilled, and then add the domain's structured data back to the nucleotide layer.
Now let's load a second set of data. Since we deleted data 2, we need a new empty layer. So as an example, we'll click the New Layer button, name a layer Shannon Entropy, and pick any color. Finally, we click Create New Layer to finish. Our new layer has been created and is automatically selected for us. Now let's put Shannon Entropy data into our new layer. We select Shannon Entropy data from the Alignment Data section and set the circle properties in the layer options to regular and filled. Finally, let's bring the nucleotide layer back on top.
Now we have a complicated 2D map where you can see the protein contacts as large unfilled circles and Shannon entropy as regular filled circles. The domains are still signified by the colors of the letters. You can see all of this information simultaneously. If you would like to turn some data off temporarily, you can click on the eye icon next to the layer name, and this will turn each layer on and off independently.
You may have noticed that the color of RNA on the JMOL panel has not changed much so far. That's because the color of RNA on the 3D side is dependent not on whether the layer is selected, but on whether the layer is linked. To visualize a layer in the JMOL panel, it must be linked to the JMOL panel by clicking the radio button in the L column. It can take several seconds to update the colors on the 3D panel, depending on the type of data you've linked. Once updated, the colors of the RNA nucleotides in the JMOL panel will match those of the data in the linked layer.
We have just demonstrated several manipulations of layers in RiboVision. By following these steps, the user can create an unlimited number of customizable layers, which may be turned on or off independently to generate various representations. This facilitates discovering new things about the ribosome. Check out our user data video to see how to graph your own data in RiboVision. This completes our tutorial on the layer panel.